Among Excel's LAMBDA methods, reduce and stack most closely mimics traditional financial modeling calculations. It processes periods one column at a time and, when needed, can reference prior columns, just like traditional financial models. To demonstrate, we will use a simple corkscrew calculation. Note: this lesson's purpose is to explain how the reduce and stack method works. For simple corkscrews, scan is more efficient, but that is a different discussion. The reduce and stack method is organized into 5 sections. The first section controls processing each period one at a time. The second retrieves opening balances. The third retrieves current period values. The fourth contains internal calculations. The fifth stacks results into columns. With reduce and stack's structure in mind, let us examine an example in detail. Reduce has 3 arguments. Initial value, which in this example we set to I13. Array, which in this example we set to the model's period counter. And LAMBDA. Reduce's LAMBDA has 3 arguments. Accumulator, which we label as ACC. A single value from Reduce's array, which we label as period. And a formula to process the accumulator and array value. Reduce starts by sending its initial value to LAMBDA's accumulator and the first value in the array to LAMBDA's array value. At this point, LAMBDA's ACC value contains 0 and period contains 1. The LAMBDA sends these values to its let function. The first let step calculates the opening balance row. If period equals 1, which at this time it does, open is set to the accumulator, which was initialized to I13. The second let step retrieves the increase value from J7 through U7 using index. At this time, period equals 1 and index retrieves 281. Similarly, the third let step retrieves the decrease value from J8 through U8 using index, which is 691. The fourth let step adds the increase to the opening balance and subtracts the decrease. At this point, the closing balance is minus 410. The fifth let step vertically stacks the opening balance, increase, decrease, and closing balance into a column. The sixth let step checks if period equals 1 and places the column in result. The last let step returns result, which is placed in the accumulator. We just completed the first value from our model's period counter. Moving on to the second period, reduce passes 2 to its LAMBDA. After the first period, LAMBDA's accumulator comes from the LAMBDA's last calculation. And in this case, the accumulator contains this corkscrew's first period column. The first let step retrieves the opening balance from the accumulator's first column and fourth row, which is the first period's closing balance. Open now equals minus 410. The second and third let steps retrieve their increase and decrease values from those rows' second column. The fourth let step totals those values. The fifth let step stacks those values in a column. The sixth let step stacks this column horizontally against the accumulator. The last step returns the stacked columns and repeats these formulas until all values from the period counter have been processed. To recap, reduce controls processing periods one at a time. Opening balances come from the accumulator. Period values from external ranges are retrieved using index. With all values ready, we perform internal calculations. Results are stacked into columns and placed in the accumulator. When all periods have been processed, the accumulator is placed in cells. We can convert this formula into a reusable function by wrapping it inside a LAMBDA. The LAMBDA's purpose is to give this function a name and to provide our formula with inputs. Edit our formula by adding LAMBDA and an open parenthesis. Add our corkscrews arguments, opening, increases, and decreases. Replace reference I13 with opening. Replace the external column counter with an internal column counter using sequence columns increases. Replace J7:U7 with increases. Replace J8:U8 with decreases. At the end of the formula, add a closing parenthesis. Copy the formula. Click Formulas, Name Manager, New. Enter corkscrew as the name and paste our formula into refers to. We now have a reusable function. Let us test it. In cell J10, type equals corkscrew and open parenthesis, then I13, J7:U7, J8:U8, close parenthesis, and then hit Enter. Converting financial model formula blocks into reusable functions is relatively easy with the reduce and stack method. Once we convert our formula blocks into functions, we can easily import and use them in other models, saving time and preventing errors.